Have you ever wondered how we predict the future? Not with some crystal ball, but with actual data. Well, today we're going to dive into exactly that. We're talking about regression, which is one of the most fundamental tools in all of machine learning for figuring out what's coming next. So let's get right into it. The prediction problem. You see, at its heart, a huge chunk of machine learning is really just about solving this one thing. It's all about taking what we already know about the past to make a really smart, educated guess about the future. Okay, but let's narrow that down a bit. Let's focus on this one single, super important question. How can we predict a specific number? I know, it sounds almost too simple, right? But trust me, this is the foundation for so much of the technology and data analysis that's all around us. I mean, just think about it for a second. What's the price of a house going to be? How much are we going to sell next quarter? What's the temperature tomorrow? All of these are looking for a number as the answer, right? They're not simple yes or no questions. They need a specific quantity. And man, getting that number right can be incredibly valuable. So, how do we actually solve this? Well, the simple and honestly kind of elegant answer is a technique called regression. It's often the very first model people learn when they get into machine learning, and there's a really good reason for that. Okay, let's break that definition down. It says it's a supervised learning technique. All that means is that we train the machine using data that already has the right answers included. We showed a bunch of examples, and from those examples, it learns how to predict a continuous numerical value. So basically, if you need to predict a quantity, an amount, a value, a price, chances are you're looking at a regression problem. But you know what? Enough with the definitions. The easiest way to really, truly get what's going on here is with a simple picture. So let's just visualize it. Picture this. We've got a basic graph. Along the bottom, that's our x-axis, we've got the size of a house, square footage. And then going up the side, the y-axis, we've got its price. Now, every single dot we put on this graph, that's one real house with its own specific size and its own specific price. So, once we've plotted a bunch of these houses, you start to see a pattern, don't you? It's pretty clear. Bigger houses tend to cost more. So what's regression's job in all this? Its job is to find and draw the single best straight line that fits right through that cloud of dots, capturing the core of that relationship. And that line, well, that's our regression line. That's the whole model. It helps us predict prices for houses we've never even seen before. I mean, think about it. We can just pick any house size on the bottom axis, go straight up to our line, and then look across to see the price it predicts. It's that simple. All right, let's make this even more concrete. We're going to use a really simple example. And let's step away from the housing market and talk about something a little tastier. Okay, so imagine you run an ice cream shop. You're looking at your sales data, and you spot a super clear pattern. Step 1, when it's 20 degrees Celsius out, you sell 100 ice creams. Step 2, when it gets warmer, say 25 degrees, you sell 200. And step 3, on a really hot day, 30 degrees, you sell 300. The relationship here is pretty obvious, right? So here's the question for you. If the weather forecast for tomorrow is 28 degrees Celsius, how many ice creams do you think you're going to sell? Based on that pattern we just saw, what's your best guess? Well, if we drew our regression line, it would predict somewhere around 260. And here's the cool part. Notice that 28 degrees is a temperature you've never actually recorded sales for. The model isn't just spitting back old data. No, it's using the trend to predict something new by basically reading the space between the dots you already have. So simple, but so powerful, and incredibly useful. Okay, but let's be real. The world isn't always a perfect straight line, is it? So just like there are different flavors of ice cream, there are also a few different flavors of regression, and they're each designed to handle different kinds of patterns you might find in your data. The two you'll hear about most are linear and polynomial. Linear regression, that's what we've been talking about this whole time. It fits a nice, simple, straight line to the data. It's perfect for those direct, straightforward relationships. But polynomial regression, that one fits a curved line to the data. It's way better for more complex trends, things that bend and change direction. So let's put them side by side. Linear is our go-to for modeling a straight line, like predicting a house price just from its size. Easy. Polynomial is for those curved lines. Think about sales that shoot up and then start to flatten out. A straight line would totally miss that. But then there's multiple regression. And this is where things get really powerful, because it understands that the world is messy. A person's salary isn't just based on their years of experience, right? It's their education, their skills, maybe even where they live. By throwing in multiple inputs, we can build a model that's way, way more accurate. Oh, and here's a quick bonus tip, because this one trips everybody up at first. You're going to hear the term logistic regression. Now, despite having regression in the name, it's not for predicting numbers. It's actually used for classification, for choosing between categories. Like deciding if an email is spam or not spam. It's a totally different beast. So just a good little fact to keep in your back pocket. All right, so this isn't just some abstract theoretical stuff. Regression is actually running silently in the background of your world like every single day. I mean, seriously, where will you find it? When you're predicting house prices on a real estate site, that's regression. Forecasting product sales for big company? Yep, regression. Estimating a student's final marks based on how many hours they studied? That's regression too. Predicting a car's mileage? Calculating apartment rent? It is absolutely everywhere. And if you look at the top application areas, its impact is just massive. You've got business forecasting, you've got scientific research, and of course the financial markets. In all these fields, people rely on it. It's truly the workhorse of data analysis. So let's just quickly recap the key things to remember. First, regression predicts numbers. Simple. Second, it does this by finding that best fit line or curve that slices through your data points. Third, there are different types like linear, polynomial, and multiple for handling different kinds of patterns. And finally, it's a simple, visual, and just plain powerful model to start with in machine learning. But the most crucial point is this. Regression is all about turning a bunch of scattered, messy data into a powerful, simple prediction. It finds the story hidden in the noise. And that brings us to one last really interesting question. We've been talking this whole time about drawing that best fit line, but how does a machine actually find it? I mean, how does a computer know exactly where to draw that line to make it the best one? How does it mathematically sort through all the infinite possibilities to pick the perfect one? Well, that is a fantastic question, and it's a story for another time. Thanks so much for tuning in.